Okay, chapter 2. You made it. One chapter down. So now we turn our attention to equations containing two variables. So what the y-axis now does come into play. This material will lay the foundation for our primary focus this semester, functions. So technically speaking, everything we just went over is a review of Algebra 1, if you would. Let's see, I think the light off is better. Sorry, sidetracked. But anyway, so we're starting our discussion on functions. So what we have to do first is introduce, of course, two variables. So, solutions to equations containing a single variable are just single numbers that make the equations true upon substitution. To picture these ordered pairs of real numbers, we use the rectangular coordinate system or the Cartesian coordinate system. So this is what is the rectangular, oh gosh, my line got a little wonky. The rectangular coordinate system, we've got the x-axis, of course the y-axis. Here is what's known as the origin. And the point here is 0, 0, right? And then we know that this is called quadrant 1. Moving counterclockwise, we've got quadrant 2. Down under quadrant 2 or diagonal from quadrant 1 is quadrant 3. And then straight to the right, we have quadrant 4. Remember that all points on the Cartesian plane are of the form x comma y. So you always move horizontal on the x-axis first, and then you move vertical on the y-axis. So all points are x comma y. In terms of their sign, remember that points in the first quadrant, all x are positive, all y are positive. What do we have in quadrant 2? Good, negative, positive. What's in quadrant 3? Negative, negative. In quadrant 4, we've got positive, negative. Good, because to the right are the positive x-axis, to the right x's, to the left we've got negative x's. So from the origin up, we've got positive y's. From the origin down, we've got negative y's. So it's kind of like your basic intro to the Cartesian plane. It's called the rectangular coordinate system because remember we've got all of these little baby squares, right? And a square is a rectangle. So that's hence the name. Remember, they called it like they saw it, I swear. So now, how about we talk about distance? Well, if I've got 2 points, point A is negative 2, 1, and B is 5, 6, then let's say here's negative 2, 1, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Oh gosh, already not to scale. If I want to find this distance right here, remember the fastest way to get between any 2 points is a straight line. But one way we know to measure things, that is, at this point, oh gosh, again, not to scale. Fairly common knowledge, hopefully at this point, is right triangle trig. Remember that if I've got a squared, b squared, and c squared, right? The legs of a triangle, oh, that's a b. A squared equals b, I can't talk. A squared plus b squared equals c squared. Oh, so that's just a, that's just b, that's just c. The legs of the triangle, right? The sum of the squares equals the hypotenuse. So we're going to use this idea to find the length of the hypotenuse. But what is A? A is the distance, right, from the height. So basically I've got 6 here and 1 here. So what's that total distance? 5. For B, we've got -2 here and 5 here. So what's the total distance for B? Or leg B is equal to what? So you've got 1, 2 plus 5 is 7. So now A squared, or 5 squared, plus 7 squared is equal to C squared. So 25 plus 49 is equal to C squared. I'm going to come up and over. So let's see, 25 plus 49, 5 plus 9, that's 4. Carry the 1, that's 5 plus 2 is 74. So C squared is 74. So C is the square root of 74. So now, quick little side work. Let's talk about how we simplify the square root of 74. So remember, if I've got the square root of 74, 74 breaks down into, I don't know, 2 and something. Let's see. 2 and go into 7 3 times, because that's 6. Drop the 1. That's 7. Oh, okay, so it can't reduce. Because 2 times 37 gives us 74, and 2 and 37 are both prime. So that's it. So that I know now for sure the distance between A and B, the distance from A to B is equal to the square root of 74. So the question is, how can we do this in general, right? Well, in general, it's still based off the Pythagorean theorem. So if A squared plus B squared equals C squared, but I only want C, then this is the square root of A squared plus B squared. But remember, what is A? A is just the distance of the y's. So I've got y2 minus y1 squared plus the distance, or the difference in space for B, the horizontal. So I've got x2 minus, x1, that's a 1, squared, equals C, which is distance. Okay, so that is how you derive the distance formula. So the distance formula is a big one for this class. So next up is midpoint. So how can I determine the midpoint, or the middle of something, right? So the midpoint of 2 points, midpoint, middle, remember, called it like they saw it. Things are labeled by what they do, say, or are. So if I want the middle of something, right, then to find the middle, you add them and divide by 2, which is also the average, right? So if I come up here to this example, if I've got -2 plus 5 divided by 2, because that's the middle, right, midway point, or the average of the 2 points, that's the x. And then we're going to do the same for the y's. So that would be 3 halves, pardon me, that's negative. 3 halves, comma, 7 halves. So let's make sure to see that this is the middle. So let's see, 3 halves is what, 1.5, so about here-ish. And then 7 halves is what, 3.5. Does X mark the spot? Hey, that looks almost midpoint. Again, not to scale, but that looks pretty good to me. So remember, you're just finding the middle. So for midpoint, it's x1 plus, x2 over 2, comma, y1 plus y2 over 2, because it's just the average. It's just the middle of the 2 points.